Hello guys, in this video we're going to talk about the worksheet 10.1a level 2 plus. So still talking about the circle theory, the angle at the center towards the angle at the circumference. Well, this is the harder one if you aim for level 4 in the DS exam. So try to understand each question and do it by yourself. So let's do the first questions. We have the AB is equal to AC, so we use a highlighter to say that the AB is equal to AC, and together we have the angle is equal to 50 degrees. And the question is asking you to find the angle BAO. So locate it first, angle BAO, so it's this angle. So every time you do this type of questions, you make sure that you locate the angle that the question is asking you to find it. So locate it first and make sure that you're not finding some wrong angle, okay? So now, as we have the AB is equal to AC, so we can write it as we have AB is equal to AC, so that we can say the angle ABC is equal to the angle ACB. They are the base angle, right? So we have the angle ACB is equal to the angle ABC, which is equal to 50 degrees. And the reason for that is the base angles isosceles triangle. So now we find out the angle here. We have a 50 degrees. So after that, how can we find it out what's the angle here? It's like there's no relationship, isn't it? But now we get like 50 degrees here, which means that we can find out this angle, the angle A. It's like the question asking about this angle, but a little bit more, but at least we find something, right? So we can find it out the angle BAC. So we can say that the angle BAC is equal to 180 minus 50 minus 50. And the reason for that is we are trying to calculate the angle sum of triangle. We want to find out the angle A by minus the 50 and the 50, so that we can say this is the angle sum of triangle. So we can calculate that the angle BAC is actually equal to 80 degrees. So now we got the whole thing. So this is our whole thing. It's equal to 80 degrees, right? So this is equal to 80 degrees. So which means that if we can find out what's the angle here, then actually we can find out what's the question asking about the angle BAO. So how can we find out? So first of all, if we notice that the OA is actually equal to OC, isn't it? Because they are the radius, so we can say that the triangle OAC is an isosceles triangle, so that we can write something like the OA is equal to OC because they are the radii. Then we can say that the triangle OAC, so that the triangle OAC is an isosceles triangle. So we can again use the base angle to find it out. This angle is actually equal to this angle, but we don't know what is that, right? We'll just keep it for a while. So now we have the angle OAC. The angle OAC is actually equal to the angle OCA. So that's the base angles isosceles triangles. So now we get the angle of this one is related with the angle OCA. So if we can find out what is the angle at the center, then we can directly find out what is the angle here. So if you realize that, like the angle O is actually watching to this RKC, so do this angle 50, isn't it? They are watching at the same arc, which means that the angle at the circumference got a relationship between the angle at the center. So now we can say that the angle at AOC is doubled from the angle of ABC, which gives you equal to 2 times 50 is equal to 100 degrees. And the reason is the angle at the center twice the angle at the circumference. So now we know that the angle at here is equal to 100 degrees. This is equal to 100 degrees, which means that the angle sum of triangle of OAC, we have this is equal to x, this is equal to x, and the larger one is 100, and all the things plus together to get the 180, so that we can write the angle OAC times 2 plus 100 degrees will give you 180 degrees, by using the angle sum of triangle, so that the angle OAC is going to be equal to 180 minus 100 give you 80, divided by 2 give you 40 degrees. So this gives you 40 degrees. So now we get the answer of this one. And as we know that the BAC, the whole thing here, the large one is 80, the smaller one inside is 40, which means that the required angle is 40 as well. So now we can write it so that the angle BAO is equal to the 80 degrees minus 40 degrees give you 40 degrees. So it's a little bit tricky, but the only reasons that we use is the angle at center twice angle circumference to get a lot of times of angle sum of triangle and the base angle isosceles triangle. So there's combination of all of these basic theories. All right, so let's move to question 2. So for question 2, we have the AD is perpendicular to OC, so we draw it first. So we have the OC is perpendicular to AD, and now we have this angle 70 degrees. So when you have this 70 degrees, means that the alternate angle, this one should be 70 as well. So you can write it down, this is equal to 70 degrees. So once you get some angles, just write it down. So now we have the angle COE. Angle COE is actually equal to the angle EDA, which is equal to 70 degrees. And the reason for this is the alternate angles OC parallel to AD. So for this X, because we got this Z, right? This Z and these two lines are parallel. So this X and this angle C is going to be the alternate angle as well. So you can write it down. We have the angle OCA. OCA is equal to angle EAD, which is going to be equal to X. And still using the angle, alternate angle, the OC is parallel to AD. So that we can write this angle to be X as well. So what's the next part we can use? So if you can look it carefully, we can say that this is OA. Sorry. So now we have this is OA, this is OD, this is OC. So all of these three lines are the radii, isn't it? So now we have OA equal to OD equal to OC, so they are radii. And which means that we have two isosceles triangle, like we have isosceles triangle OAD together with this OCD, but we're not using this OCD at all. So if you look at this OAD, as these two lines are the same, which means that this is gonna be the base angle, isn't it? So we can say that the angle OAD is gonna be equal to 70 degrees, and the reason is the base angles isosceles triangles. So now we can say this whole angle is going to be 70 degrees. So the question is asking you to find out what is X and Y. So how can we do that? So if you look carefully, you can see that if this is 70, this is X, isn't it? So they are looking at the same arc. I use the blue line. So if we're looking at the arc CD, it's actually this angle at the center is actually twice angle at the circumference. So we can say that the angle CAD, which is X, is equal to the half of the angle at the circumference, the center, so the angle COA. Then we can say that the X is going to be equal to a half to 70 will give you 35 degrees. And the reason using here is the angle at the center twice angle at the circumference. So I will say again, because this COD is watching to this arc CD, isn't it? And so do this X. This X is watching to the same arc as well, but our O is at the center, which is the angle at the center, and this X is the angle at circumference. So the angle at the center is twice angle at the circumference, so we can find out the X is actually 35 degrees. So after you find this, how can you find out what is the value of y? So if you look at carefully, the y is watching to this whole line AC, and so for this COA, so this COA is watching at the same arc as well. So the angle O, the whole angle O, actually is doubled of the angle y. So if you can know that what is the angle of AOD, and then we plus the OC, take it half, then we have the value of y. So now we can find out what is the value of AOE. So as we have, this is 70, this is 70, so we can use the angle sum of triangle to find out the angle AOD is actually equal to 180 minus 70 minus 70, so that we have the angle AOD is equal to 180 minus 70 minus 70. So in total, this one will give you 40 degrees. And the reason for this is the angle sum of triangle. So now we can get this angle is equal to 40. So now we can using our angle at the center. So this is 110. So that's the angle at the center twice angle at the circumference. So now we have the angle AOC is actually equal to the twice of angle ABC. The reason for that is angle at the center twice angle at the circumference. So we can say that our 40 plus 70 is equal to 2y. Then we can say that the y is equal to 110 divided by 2, give you 55 degrees. So we have x is equal to 35, y is equal to 55. So that's for question 2. Alright, now we can move to question 3. That's the half circle. Actually, we got some theory on the next part, but in this exercise, we don't need to use that theory directly. But actually, so if you look at carefully, we now have a semicircle, and we have the angle ABO is 60 degrees, and we have the angle BDC is equal to 43 degrees. Like, this is quite hard to look at, but once if you draw like a whole circle here, if you draw back a whole perfect circle, oh my god, it's so hard to draw. So if you draw like this, or I just draw whatever, I just draw a normal circle like this. Okay, so actually this O, any angle at here is gonna be the angle at the center, and any angle near the circumference on the circumference is gonna be the angle at the circumference, isn't it? So now we can watch it carefully. For example, this 43 is watching to this arc BC. So do this angle BOC, isn't it? So the angle BOC is the angle at the center, which is twice angle at the circumference. So this one will give you 86. So when angle this is 86, it's watching to BC. There's one angle is watching to BC arc as well, which is the angle BAC. So this angle is actually half of the angle at the center. So this angle will give you 43 as well. But once you find out an angle, we need to write it down first. So now we have the angle BOC is equal to 2 times the angle BDC. The reason for that is the angle at the center, and it's twice angle at the circumference. So now we have the angle BOC is equal to 2 times 43, give you 86 degrees. So now we write down something again. We have the angle BAC is going to be equal to 86 divided by 2, give you 43 as well. So again, this is the use of the angle sum. The angle at the center, and which is twice angle at the circumference. So now we got this 3 ideas. Then what's the next step that we can do with? So for example, if you look at this radii, is there any radii that we have? We actually got this radii OA and OB, is it? And we still got like the radii OC and OD, but just whatever take 2, then you can gonna fit it. So if you write it down, so now we have the OA is equal to OB by using the common radii. So what's that mean is, we understand that these two lines are the same, so the base angle are the same as well. So now we can say that the angle OAB is equal to angle ABO, which one will give you 68 degrees. So the reasons again is using the base angles, isosceles triangles. So now we find out the base angle are 68 as well. So what's the angle that we are requiring to find, which is going to be the angle OAC. So it's this angle here, so just in the middle here. So what's the angle here? Then we can using our angle OAC is equal to the angle OAB minus the angle CAB. Then we can say this is equal to, you're using the total 68 minus the small part 43. 68 minus 43, this one will give you 25 degrees. So this is not that hard, but actually there's some quicker formula to use with in the next chapter. In the next sections. So this is an HKD questions. It's a little bit hard, but not that extremely hard. So first of all, you need to remind yourself what's the meaning of a rhombus. So like a diamond. So how can we use the property of it to finish these problems? So first of all, as this is a rhombus, so which means that we have the BA is parallel to BE, and BC is parallel to AO. So we can try to write it down. We have the AB are parallel, and we have the BC are parallel. So that's the first thing that we have. And the next thing that we have is the angle BCO is equal to 134. So we have an angle which is actually inside and outside the circle, which is 134 degrees. So if you still remember that when you have like two parallel lines, and then their interior angles add up will give you 180. So that we have, the BC is parallel to AO by using the interior angle. The BC is parallel to AO, which is the properties of rhombus. And actually, we now can say that the angle BCO plus the angle O plus the angle BC OCB is going to be equal to 180 degrees. What's that mean? Because these two angles are interior angles and they got the parallel lines near it. So we have the angle AOC is equal to 180 degrees minus 134 degrees. So this one will give you 46 degrees. The reasons for that is the interior angles, and we have BC is parallel to AO. So that's how you find out what is the angle here. So this angle is going to be 46 degrees. And now if we want to find out the angle CED, which is actually this angle, then how can we gonna do? If you look at carefully, you can actually find out an angle at the center, and we have the angle at the circumference, isn't it? So actually this is the angle at the center because they are at the center, and it's watching the arc, the circumference, and together we got this CD. We got this CD which is at the angle at the circumference, so we have the angle at the center which is angle AOC is doubled of the angle CBE. Then this one will give you the angle of AOC. Angle of AOC, which is 46, is equal to 2 times the angle of CBE, which means that the angle of CBE is equal to 23 degrees. So now we have this angle is going to be equal to 23 degrees. So what's the actual value that we need to find out? Actually, we want to find out is this CED. So CED, how can we find out? So for example, if you have CED, if you want to find out CED, and if you plus this angle CDE, is actually equal to our external angle 134. So because if you turn around your iPad, you can see that this is our top angle, this is our adjacent angle, and this is our hypotenuse angles. So actually, we can say that this is a exterior angles. Then we can say the angle CED plus the angle EDC is equal to the angle ECB. So that we have the angle CED, what is the question we are asking, angle CED plus 23 degrees will give you 134 degrees. So that we have the angle CED, have the angle CED is equal to 101 degrees. So that's for question 4. Okay, let's move to the last question. It's actually a really easier one because this is a parallelogram, which means that, so for parallelogram, we have these two are parallel, these two are parallel, and these two lengths are the same. So if we connect them, if this is the radius, this is the radius, this is the radius, and so to this one and so to this one are the same. So if you consider about the triangle OAC, so first of all, you can write it down. We join B and O, so that we have the OB equal to OB equal to OC equal to BC. So when we have these three lines are equal, which means that this is an equilateral triangle. So now we have the angle of angle CBO is equal to 60 degrees. And the reason for that is the equilateral triangle. So now we say that this is equal to 60 degrees. Then how you find it out the angle of ABC? So when you find an angle ABC, which means I need to find out what's the value here. So if you still remember that in a parallelogram, which means that the angle nearby the symmetry line is going to be the same. So this is 60 degrees as well. So now we have the angle ABO is equal to 60 again. So the question is we're asking ABC, which is going to be 60 degrees plus 60 degrees give you 120 degrees. So that's it. So this is for the solution videos of this worksheet 10.1a level 2+. It's a little bit hard, but it's not impossible to do with. So try to understand each step and ask me if you have any questions.